All right, guys, welcome. Sign-in sheets. Please sign in. Oh, of course. So during the first 3 or 4 weeks of the semester, we have to do the post-course participation, I think. So you have to sign in. I have to report that. All right, welcome. So you're all here for ITS 365, right? Machine Learning Foundations. Okay, so I know some of you, right? Like half of you, and then the other half I don't know. All right, so welcome. So this is a machine learning course meant to be like your first machine learning course. I think some of you have already taken Intro to AI, right? So you took that course. And so this is machine learning, so a subset within AI, right? So we'll cover that this semester. All right, so on the agenda today, I'll go over the syllabus and then just address, those things, administrative things. We'll go over a few of the concepts, kind of give you an idea of what this course is about, some of the tools, technology that you need for the course, and then we'll just get into it. Okay, so I'll give you some basic introduction. All right, so this is a lecture and lab course. So we meet on Mondays and Wednesdays from 2 to 3:40. And usually we'll have some kind of a lab assignment every week that you need to submit. All right, so let's get started. So we'll be using Brightspace, right? So I'm sure you're all familiar with Brightspace. So you can see this is Spring 2025, 365 Machine Learning Foundation. So most of the materials are going to be in the content. Now, I use basically two resources for materials, either Brightspace or my GitHub, basically. So you have to become used to that. I'll sometimes link things, but just be aware, most of the code examples are going to be on my GitHub, and you can get them from there. This is not, although this class involves a lot of code, it's not a coding class in the sense that I'm not teaching you coding, and I rarely ask you to just write a script from scratch, right? So I will provide the code and explain. So the course is more about algorithms, if you want to think of it that way. So you really have to understand the algorithm itself, how it works. And of course, I'll provide the examples. You do, however, have to be able to read the code and change the code, right, for your own problem that you're trying to solve. But that's kind of the idea. So every week we'll study, okay, what's a Hopfield network, right? So what is that? Or what's a perceptron, or what is a KNN, or whatever it is, right? And so we'll learn the algorithm and technique, what it's for, what are the advantages, disadvantages, and things like that. At the end of the day, it's like you have this toolbox of machine learning things that you have in there, and you want to know when to use them. Right. And again, the recommendation I give to all students is usually just, if you haven't done so already, get a GitHub account, right? And you can use that as an extension of your own memory, right? So you have your code there whenever you're doing something, you're like, oh, I'm just going to look up how to do a deep neural network in my own GitHub and then modify it, things like that. All right. So yeah, that's kind of the idea. So this is Brightspace. As I said, I have a table of contents. You can see here a lot of the topics that we will cover all semester. I kind of divide the class into like 3 sections, 3/3. So the first one is kind of going over like the very historical algorithms, like at the beginning, what were the important techniques. So maybe call it the traditional machine learning and the machine learning pipeline. Okay. We'll obviously define what machine learning is. The second third of the semester is where I cover neural networks. All right, so that there, I do like to get as far as creating a deep neural network with PyTorch, just so that you have, the state of the art, right? So that you have some sense of how to do a powerful algorithm. And then in the third third of the semester, we'll just go over special topics, right? So special techniques, additional important things like maybe processing images with a really powerful tool called a ResNet or something like that. Does that make sense? So that's kind of how the course is going to go. As you can see, I'm recording the session. Here, I think. So I'm recording the session. I'll usually record the lectures and labs, and I'll post them on the YouTube channel, and you can just get them from there if you want to, if you miss something. So you don't have to, like, if I'm typing code or going over code, don't worry. It's either on the recording or I posted it already on the GitHub, so you can just get it from there. Try to understand instead of just trying to, copy everything that I'm saying and write it down. Okay? Make sense? Yeah. Did everyone sign in, guys? Yeah, so he hasn't signed in over there. All right. So let's go back to the. All right, so table of contents. So everything is here. So I'll start here today. Admin is basically the syllabus. So I'm sure, we'll go over grading, homework assignments, and everything like that. Then we'll go over all the other sections. And then finally, as you can see, getting into the contents of the course, the algorithms, etc. All right, so let's start with the syllabus. So this is spring 2025. The course is, as I said, machine learning foundations. It's meant to be your first machine learning course. But as I said, you have taken the Intro to AI course, where I'm sure you covered some of these topics. You covered the NumPy library and a few other relevant libraries, right? So that's good. All right, so I'm Professor Calix. My office is Anderson 238. That's my email. Office hours are going to be Mondays and Wednesdays, 11 a.m. to noon, or 4 p.m. to 5 p.m. Okay, Mondays and Wednesdays. Those are, I'll be in my office. Otherwise, you need to email me and by appointment, schedule. So I'm usually there Tuesdays and Thursdays too, but just give me a heads up. All right, so let's go over the course description. So I'm sure you guys know, actually, before we get into the description, I'm going to ask you guys some questions, right? So, because you've taken Intro to AI. So what's the difference between AI and machine learning? So AI is the buzzword, right? So AI everywhere. You hear machine learning less, right? But what's the difference between AI and machine learning? Are they exactly the same? No. So, but it's difficult. It's not clear, right? So, you want to, yeah, go ahead.
Doesn't like machine have like layers to it? Yes.
Okay, layers.
Like layers.
Neural layers. Okay. All right. So the way that I would say, right? So the difference is AI is the broader topic, right? And machine learning is a subset of it. And the layers thing, the neural networks, is a subset within machine learning. Do you see what I'm saying? So we'll definitely, as I said, look at neural networks because that's really the powerful tool today, right? Is neural networks. And so at least half of the semester will be that, right? Neural networks. And actually the first third, I will cover the perceptron. It's just the perceptron was what neural networks were in the 1940s, right? So back in the day. And so a lot of the course is about neural networks, but there are other techniques that I do want you to know about, which are not neural networks, but they are still machine learning. So artificial intelligence is the broader area, right? And then, as I said, machine learning is a subset of AI. And the key thing is, as the name implies, machine learning. So the idea is that in machine learning, you have algorithms, techniques that learn from data, right? That's the key thing, right? So you have some data, however and there's many ways that you can prepare this data, and then that data is fed into an algorithm. The algorithm learns, it can do things over time. It looks at more data and it updates its learning, and it can continue to learn over time. Do you see that? So, but it's looking at data. And one powerful tool for this is to use networks, these things called neural networks, which we will study extensively, but there are other techniques. So for instance, there's one technique called the K nearest neighbor. It's an algorithm that you can, in 10 lines of code, you can implement, and it works. And the joke I kind of like to say about this, let's say that right now, to build a neural network, you can build it from scratch, but to build a really powerful one, you have to use a lot of libraries, etc. But a KNN is something that you could go to another galaxy and somehow build a KNN from scratch. You know what I mean? You don't need any libraries. You can just, and so we'll go over that idea. Okay. But yeah, so does that make sense, guys? So the difference? All right. So the difference is machine learning is just a subset of AI. So AI covers other areas as well. You can build algorithms that are just if statements. Think about it, right? And that could be an AI, right? So, or it could be a tree. So for instance, when IBM built something called Deep Blue or Big Blue back in the 90s, that program was able to play chess, and actually it defeated the champion of chess back then. So, and that algorithm was really just using like a tree type of a data structure. And it really was just looking at, had if statements, etc., to make decisions on how to play chess. And that was actually powerful enough to defeat all humans, right? Does that make sense? But that wasn't machine learning, because it wasn't like learning that structure by itself, looking at data. A human actually, or a team of a lot of people at IBM that knew how to play chess, I suppose, created this tree, right? And if you ever did like depth first search or breadth first search in your data structures, classes, etc., then you know what I'm talking about. You know how to implement these algorithms. So hopefully in AI, you do things like that, right? A lot of searching, a lot of trees and algorithms like that allow you to and actually those tools are still used today. Like you can still build a very powerful neural network that also uses a tree to search for information. And if you combine those two things, it makes it even more powerful, right? So there's an algorithm called A star. I'm not sure if you covered that in your AI class, but if you did, that's still sort of AI, but it wouldn't be machine learning. You could use that with machine learning to build a more powerful system. Got it? And then, as you said, neural networks, deep learning is a subset within, is one of the set of algorithms that we can learn about in a machine learning class. All right, so hopefully that clarifies things. So what do you guys think about AI in general, or machine learning? Are you concerned that it's going to take your jobs in the future? Mildly concerned?
Don't have software engineers doesn't.
Yeah. I think, do you think that a lot of this is hype, or do you think it's real? You know how it could just be that people are just saying things, right? And it doesn't turn out to be true. But what do you guys think? Do you think there's that it's possible that there's a probability, like a 50% chance that it could replace your jobs? Go ahead.
I think,
Mhm.
oh, I'm taking a position. Let's say you're 10, now you have 5.
Yeah, I agree with that, actually. I see it the same way. If you remember the 19, what is it, the 90s maybe, or the 80s, right? So you had a lot of people that used typewriters, and you had to employ, as you said, like 30 people, and then you brought in computers, and now you just needed 5. And I agree with that. I think that's the same thing that's going to happen, at least in the next 5 years, that especially companies right now that employ a lot of software engineers are probably thinking, okay, let's not hire anyone. new people. And let's just keep the people we have and try to add these AI systems so that maybe you have like the senior engineers, the mid-level engineers, but the entry-level ones, some of them can be replaced with AI tools. It's possible. So it's really interesting what is happening. So I think knowing about these systems is really important, right? Because it's going to help you to, if you know how to use the tool, then it's going to improve your efficiency. So I think that's the other thing that people are saying is that it's not going to replace jobs necessarily, but it's just going to increase efficiency and productivity. So if a software engineer was able to, create 2 apps, now they can create 4, maybe, so it increases productivity. Does that make sense? So nobody knows. I mean, obviously we can't predict the future, right? But it's definitely a very interesting time. All right. So anyway, let's get into the course description. So this course provides a basic introduction to the machine learning pipeline and related concepts. Okay, so topics covered include machine learning uses and applications, data set requirements, data processing, data annotation, validation, data representation formats, feature representation, and extraction. So as you can see, all of this here relates to the data. All right, so a big component, and actually probably the most challenging part of machine learning, is not the algorithms. You'll spend a couple of weeks on an algorithm, and I promise you, at the end, you'll understand them. And you don't have, so one thing about machine learning is that you don't have to create new algorithms, right? So you rarely, every 4 or 5 years, you get one new big technique. But otherwise, you're just using the same technique over and over. And really what you need to understand is how do you get your data into the right format that will fit into that algorithm? You see that? So if you're thinking of a role as a data scientist, that's really what you're going to be doing all the time, is taking data in a raw format, right? And just processing it, converting it to a specific format, and then choosing, okay, which algorithm do I think will be best for this? That's it. So at the end of the day, you will understand the algorithm. You may enhance it a little bit, but really your job is going to be taking the data, putting it in a format that fits into the algorithm. Got it? And that's really what you're going to learn here. So that's why the focus of this course is going to be either in taking raw data and converting it into these specific formats, or in just understanding how the algorithm works, right? And just having some intuition of the algorithms themselves. We are going to look at code, though, and we are going to look at how they work, right? That's really the idea. We want to understand them. We're also going to look at something called the vector space model. So this is really important, a very important concept that you need to understand in machine learning. It's basically a geometrical way of representing data. And this is critical to everything that happens in machine learning. So we'll look at that. Then the focus is on traditional machine learning algorithms. So I will cover not all of them, as I don't have time to cover every single machine learning algorithm, but I will cover some of the most important ones. KNN, which is the k-nearest algorithm. That actually is really important for you to understand the vector space model. It's a geometrical way of creating a machine learning algorithm. We'll look at the perceptron and its evolution into deep learning. So the perceptron being the first neural network, really, and then all the way to what deep learning is. Okay, and everything in between, how that evolves. We will look at something called the Hopfield network. The Hopfield network is basically an algorithm that's really interesting. John Hopfield just won the Nobel Prize for that algorithm, right? So if you've been following the news, 2 AI people just won the Nobel Prize in physics for their contributions to artificial intelligence. Geoffrey Hinton for his algorithm, restricted Boltzmann machines and Boltzmann machines, right? And then John Hopfield for the Hopfield network. These algorithms were invented in the 80s, right? So in 84, somewhere around that. And they were critical because they, you know, were the first ideas, or they had this idea of gradient descent, which is the main mechanism used to train these models, right? So they got the Nobel Prize in Physics in 2024. All right, so those are some of the traditional algorithms that we will cover, but there are, different. So there's neural networks, there's geometrical approaches, there's these approaches called Bayesian approaches, and then there's like these other algorithms called tree-based algorithms. So for some of these algorithms, I may not have time to cover the algorithm itself, but we will learn how to use it. For instance, something called XGBoost. XGBoost is a tree type of a machine learning algorithm. So there's, studying all these algorithms would take a lot of time, but you'll learn how to use XGBoost, as it can be very powerful. It's a non-neural network approach, but it can be, sometimes it beats neural networks actually, and for specific types of data sets, what are called tabular data sets. And so we'll cover that as well, as you see those sometimes win competitions. So we'll cover traditional machine learning algorithms. We'll cover machine learning algorithms and programming, obviously. So we'll be using Python and PyTorch for most of the semester, and NumPy actually. So in a course like this, I actually like to code some of these algorithms from scratch. And so we want to do this with a library like NumPy, which I know you've covered in your Intro to AI course a little bit. All right. Obviously, whenever you're building a machine learning algorithm, you need to know how to evaluate it, how to measure the performance of the algorithm. So we'll be looking at evaluation methods, okay? For the different, if you're building a classifier that, tells you if an image is of a cat or of a dog, how do you know that it actually performs? And then, as you can see, I will give an introduction to deep learning algorithms. So deep learning is neural networks, but very sophisticated neural networks have layers, as you said, right? So that's why they're deep. They have this idea of layers. So I need to explain what all of that means, and it'll take a while, right? So I'll use about 6 weeks for that idea, starting at around week 7. So we'll cover that. And the idea with this is we'll do this with PyTorch, so that we're actually looking at something that is state of the art. All right. So this is how you would today, implement a deep neural network using PyTorch. We'll talk about CPUs and GPUs. We do have GPUs available for you guys to use, given that the university provides for us a cloud type of service called Scholar. Right, so I'll make that available for you guys. And then the key thing there is it's a queuing system. So you have to go in, request a GPU, and usually you can get it right away. But it could be that it's busy. So if you have we're not going to use it for live demos in class, but you certainly can use it for homework assignments and things like that. All right, so I will provide that information later in the semester, but you will be able to use GPUs. Big data, we'll talk about big data, and then some special topics like reinforcement learning, unsupervised learning approaches, self-learning. So you can see special topics here. So machine learning is huge. I can't really, I can't cover everything in a course like this. This is definitely an introductory course. We do have courses. We have a 520, which is just PyTorch, for instance. We have 530, which is transfer learning. We have visualization course. I mean, there's a lot, right? So high performance computing. So there is, in fact, a concentration, I believe, in data science. So there's a lot of courses, but this is, starting sort of at the beginning. All right. So this week I will cover the machine learning pipeline. So we'll discuss what that means, but basically is, in the simplest form, a machine learning algorithm is a function that takes in an input and produces an output. Okay, that's it. Input, output. And that function can be represented mathematically, usually, right? So it's some kind of but you can also think of it as code a function with operations inside. So we'll discuss that. So course objectives, you can see here the topics, the machine learning pipeline, extract data for machine learning in the context of big data. So what do I mean by big data? So I'm sure, how many of you have used ChatGPT? Yeah. If you haven't done so already, sit down and just chat with ChatGPT for a little while. Ask it whatever you want. And then I think it'll really change your perspective on the future of the world. But it's really impressive what it can do. ChatGPT is basically a deep neural network, a very, very deep neural network, very deep, very big structure, right? It's based on that, but it's much more than a GPT. It's got like layers around it. It may have some search trees around it. It's not even clear because ChatGPT is actually a product produced by OpenAI, and they really don't tell you everything about it, right? Because they don't want competition. But the way that we know, that we can start to understand how it works is because companies like Meta, for instance, they want to also understand how it works. They have very smart people, right? So when they look at something like ChatGPT, they can kind of like, figure out how it works, right? And then they create copies of that. So for instance, Meta creates something that is open source called Llama, the Llama models. And they're basically just trying to create an open source version of ChatGPT so that everyone understands. They don't want to fall behind and all that. So anyway, going back to this idea of big data, so ChatGPT, which is a GPT, was trained basically on all the data in the internet. Think about that idea, right? Everything on the internet was given to ChatGPT to train on. So the first ChatGPT probably trained for about 3 months on at least 1,000 GPUs, all working in parallel, and it probably cost like $8 million to train. The first one, right? I don't even know new versions of it. But that's what big data means. Big data means not like what in this class, obviously, we can't give one of these models all the data in the internet. We just don't have enough resources. We don't have enough computing power, right? But companies like Meta, Microsoft, probably Google, certainly, they have the models called Gemini, and then something like OpenAI, Anthropic, right? So they spend a lot of money on GPUs, and then they can, in parallel, give all this information to these GPUs to be trained. Okay, so that's what big data means. Yeah, go ahead.
All of that data collected in the first place, though, like doesn't someone have to manually code like to grab all of that data and process it?
Yeah, it's web scraping. Have you heard of a crawler? That's what Google had initially, right? So if you know how Google works, Google has it's just software. It's just some code called a crawler. That's the algorithm. And all it does is it'll take, let's say, a list of 10 links, and it grabs the websites, and then it parses them with something like Beautiful Soup. And those websites have what? More links. So you grab those links and parse those websites. And what do those websites have? More links. So then you grab those, parse them, and you can crawl the entire internet that way. Everything that is not behind like a paywall, or if you have to sign in, or the deep network, what is it? The deep internet or something like that.
Dark web?
Dark web, there you go. I don't think they can access that because it's behind certain things. But everything that's public on the internet certainly can be crawled. And that's what I mean by all the internet.
Oh, so basically all they would need to do is use something like a crawler to just crawl through the internet continuously.
I mean, that's how Google has been doing it for 20 years, right? And then there's people, so actually the data sets are available. So Meta, when they created their first Llama model, they actually provide on their website all the links to the data sets. They're really massive, but one of them is called the web crawl, for instance. And that's not all that's given to one of these models, because you also give it a whole bunch of books. So if you think about it, Google, for instance, has scanned a lot of books and has them available. I'm sure there's also the Project Gutenberg, which has a lot of books that have been converted into text. And so the amount of data that was given to those models, like the original ChatGPT, is basically you gave it the web crawl plus a lot of books plus a lot of other resources. And if you think about it today, Google owns YouTube. So they have access to, if you've ever used YouTube and uploaded a video to YouTube, they could use that to train a model as well. Because they can convert, like, let's say I'm doing this recording right now and I will add this video to YouTube. In a week or so, they're going to transcribe everything I'm saying into text. And then they could use also that text to train their model. Because I'm saying things that make at least some sense, right? So they can use some of that information to just continue to train the models. So it's massive amounts of data, like literally massive amounts of data. And that's why they coined this term big data. Got it? Yeah. So all this, so imagine all the books in the world, basically, all the internet in the world that's available publicly can be crawled, and it has already been. They're not even doing this in real time. All this data was crawled at some point, was made into a repository or a data set, and then they just provide this information to these models. And as I said, I don't know the statistics of like models like Gemini, but the original GPT for ChatGPT was about 3 months, at least 1,000 GPUs, and I think $8 million. And that was what, 2022, I think, right? When ChatGPT became a thing.
Or like
When was it?
20s. I have no idea.
Yeah, I think it was
Or,
22.
like,
It was after the pandemic, I think.
all the ChatGPT, like
When the moment that everyone learned about ChatGPT was 2022, I think, but I don't know. Yeah, late 2022. But the algorithm actually, so think about this, the algorithm that ChatGPT is based on was invented in 2017. And that algorithm uses neural networks, which you can go back to the 1940s and so on, right? So everything builds on it. Yeah. Yeah, go ahead.
Transformer.
The transformer, yes, exactly. The transformer was invented in 2017. The paper, attention is all you need. Yeah, it's called a transformer. So that paper came out in 2017, and basically something like ChatGPT is based on the ideas in that paper. Yeah, but that paper does not make a ChatGPT, right? You have to do additional things to get a ChatGPT that is as powerful as OpenAI's ChatGPT. All right, great. So that's important. Big data means that, giving it massive amounts of data. Just to give you, so really today, to be able to train a ChatGPT, you have to have thousands and thousands of GPUs. So that's why the industry of like data centers is becoming very important, right? So because you need to have all these computers, a lot of them are just using the cloud. So I don't think OpenAI or Anthropic actually own a data center. Instead, they're just, so basically their entire budget for a company like OpenAI is really the people, which earn between $300,000 and $800,000 a year, and the data, which is free, at least today, and then GPUs, renting GPUs in the cloud. That's essentially what you need to create one of these AI companies. Smart people, money to pay cloud services, and hosting of the application, etc. That's it. So just to give you one last statistic on GPUs, the last time I checked, Elon Musk and Meta were creating these massive clusters to support their AI endeavors. And I think currently Meta has a cluster of 650,000 GPUs for use. I'm not saying that's one computer, but they may create several little clusters in there. But they've invested money to have 650,000 NVIDIA GPUs. And Elon Musk also did the same recently for its Grok solution, somewhere around 700,000 GPUs. Keep in mind, one GPU costs 2,500, 4,000, something like that. Yeah, go ahead.
So what kind of hardware are they buying for this stuff?
Hmm?
Like, are they buying like the RTX series, or is there like I thought there was an NVIDIA series that they were.
Yeah, I have an RTX 20 because I bought mine like in 2020. It still works. It's kind of a good one that I bought, a workhorse. But the RTX series I think is 4,000 to 5,000. Yeah, 5,000, but they don't use that. They don't use that. Do you have a just came out, right? But they don't use those. In fact, neither does the university. So our Scholar solution will have these A30s and H100s.
Something maybe like, well, it's a developer card, NVIDIA pops out the Quadros.
I don't know that one.
Yeah.
But so so Scholar uses, you'll see when we start using that, it'll say H100 or A30. So those are more, so I think the RTX are more for like the consumer market like us. And then for a cloud type of service, you'll buy something like an H100. I think maybe H200. I honestly don't know. They're constantly pumping out these GPUs. Go ahead. Yep. They'll have more cores, more memory. That's the key thing. Yeah, they're expensive. They're really expensive. In fact, you can buy these computers that have 8 GPUs on them. And so they're not even thinking about buying one GPU. What they buy is like the whole unit of 8 GPUs, and then they buy another one of those, and then they scale up. Because there's an advantage when you're building these things like this, because a motherboard will have a bus that connects 8 GPUs, and that's going to be much faster than having a GPU on one computer and a GPU on another computer that have to connect through the network. Do you see that? And they have really good networking connections also. They have something called InfiniBand, I think, or something like that, which is like specific for that type of work. But as you guys know, the bus inside the motherboard is always going to be faster than the network connection. So building these clusters and managing them is actually really hard. Okay. If you're good at that, you're going to make $1 million in your salary. It's like crazy how that is probably one of the most important skills in AI. Not even knowing the algorithms, but just knowing how to build these very big clusters. That's why NVIDIA is basically like, they're the ones that are making the most money out of AI right now, because they're the only solution in town for everyone. So Meta, I just told you, Meta just bought 700,000 GPUs. XAI, which is Elon Musk's, also bought around 700,000. Google, even though they have their solutions, they have something called TPUs and things like that. They still, I'm sure, use GPUs, the NVIDIA GPUs, I should say. All right, so big business there. All right, moving on. So we've talked about the hardware, and as I said, you'll get to play with GPUs and learn more about them through Scholar. Okay, so once I will provide. So one thing that I like to do in this course is I like to find a really large data set. Now, I don't mean something like what you give ChatGPT, but I'll give you a data set of about 70,000 images. And that is really big for a laptop using neural networks. So if you try to train a model with 70,000 images using a deep neural network, good luck, right? It would take you 4 days and you'll become very frustrated, trying to do that. So at that point, you'll learn that it does make sense to switch to the GPU, because in the cloud service, you'll see that it's way faster. It might take an hour for something that would take a couple of days on your laptop. Does that make sense? So we will cover examples of that in a more realistic, setup. All right. So anyway, moving on. We want to understand, as I said, besides understanding the environment and understanding the algorithms, a lot of data science and machine learning is really the data. I'll teach you a few techniques, but that's really where you have to know how to code a little. okay? Because you have to know how to get data from images, data from text, from networking information, and convert it into formats that we can use for machine learning. And usually you just have to write that code in Python. So that's going to be something like data pre-processing techniques, creating features. So I'll spend a lot of time teaching you this, what are features, feature extraction, the vector space model. I'll give you an idea of that. And as I said, traditional machine learning, deep learning, etc. And then there's special topics that I can cover. That's in the last third of the semester, and I haven't really decided what I'm going to do because it just changes so much, right? So I'm trying to decide what might be the more interesting or useful thing to cover. All right. Course prereqs. So you guys should have a programming course, right? Like ITS 140, which is a Python course, I believe. So I'm sure you've taken that. And then you are taking a stats course, maybe with this class, or you've already taken it, right? And then you took the AI, Intro to AI course. So that's kind of your background. Textbooks. I don't require any textbooks because I give you all the code basically and all the notes and everything. But if you want to get a book on just machine learning that is uses Python, I would recommend Python Machine Learning by Sebastian Rashka, the latest edition, basically. If you want to get a book, you don't have to. You don't have to. But that's probably the best book that you can get. Okay. And then there's also this other one, data mining. So I will cover a tool called Weka, and this book goes with that tool. Weka is a nice GUI-based approach to machine learning, but that program is so easy to use that basically in like one lecture, I can cover it and you'll understand how to use it. So it's something that I provide because I do think it adds value and it'll help you to understand a lot of the machine learning, not the algorithms themselves, but how to use them really quickly. All right, so we'll look at Weka, I think during week 3. All right, so here's a more detailed description of the topics. The libraries that I'm going to use are Python. We'll use the sklearn library. We'll use PyTorch. And then, of course, NumPy and Matplotlib. Those are the essential libraries for this course. And so the software. And then I've covered this already. This is just a little bit more specific. All right, so let's take a look at the course grading. So this class has a project that is 20% of your grade. It's got assignments, which are 40% of your grade. Exams are 30% of your grade. There will be 3 exams. Exam 1 on week 6, exam 2 on week 12, and then the final exam during finals weeks. As you might imagine, these exams are just about understanding an algorithm. So I will say, write 10 lines of code and explain how hop-field networks work, right? So that it'll be that type of a question, or write the code and implement the KNN algorithm, right? So you have to understand the algorithms, basically. All right. Participation, that's 10% of your grade. So it may just be attendance, or if I do pop quizzes, which, that is also tied to attendance. So basically, if you attend class, you'll get 10 free points. Questions about the grading or anything so far? Yeah. Yeah. They're closed book, but you're allowed a cheat sheet. They're closed notes, they're comprehensive, and you're allowed your cheat sheet. They're written exams.
Very like specifications for the cheat sheet.
One of these pages, 8.5 by 11, whatever you want to write on it. You can bring a magnifying glass if you want. That's fine.
Very cool.
All right. Any other questions? All right. Yeah. So I think that's the syllabus. Read through it, please. There's a lot of instructions, attendance. The one thing I will say about homework assignments is please only use Brightspace to submit your homework assignments. Don't send me homework via email, okay? That just, there's no way I can get through all those emails. So I can't accept homework that's submitted via email. Instead, submit it on Brightspace on time. Okay. Every week I will you may have a homework every 2 weeks or so. And it's usually going to be assigned on a Wednesday, right? And you'll have about a week or two to submit it. Okay. Essentially, it'll be I explain an algorithm, and then I'm going to give you some data sets, and you just have to use that algorithm with those data sets to build a model and then evaluate the performance of the model. Okay. So, oh yeah, please. That's a good question. How much coding is involved with the assignments? So as I said, I don't require you to write code from scratch. I will always provide the full code example of how an algorithm works. However, you do have to know how to read code. That's essential. And you have to know how to modify it. So for instance, let's just think of the example of a neural network. I may give you an example of a 2-layer neural network, and I'll say, yeah, do this, but make sure you use a 4-layer neural network. Do you see that? So you would have to know how to modify it for that, and the challenge of the data, right? So you have to know how to, I'll provide obviously a lot of examples of how to read data from a text file into RAM for your model, but I'm not going to give you the exact code for that specific data set that you might use for the homework. Does that answer your question?
Yeah.
Yeah. But yes, code is essential here. The only tool that we will use that doesn't use code is Weka. That will be more of a GUI type of approach. Otherwise, it's all Python. But that's why I provided my GitHub. Yeah.
Python. Does it really matter what we do? Like, kind of.
What do you mean?
Python has its own development environment.
Oh, the IDE?
Yeah,
Yeah, the IDE, I use Anaconda, and I'm going to use Jupyter Notebooks essentially. So I will demo that actually this week, how to get set up with Anaconda. I mean, you could use other IDEs, that's fine. But my examples will be with Jupyter Notebook. How many of you have used Jupyter Notebooks before? I think, well, if you haven't used Jupyter Notebooks, you'll like them. I can tell you that. And then you just have to, a Jupyter Notebook basically allows you to run code and then gives you the printout of the results or the image or whatever it is. So it's really useful that way. And then you just have to learn how to convert that into a PDF to submit. One thing I'll ask you, please don't submit Jupyter Notebooks or scripts as your homework assignment. You can add those as attachments, but I usually want a report, either a PDF or a Word document summarizing and addressing everything. Does that make sense? So you can submit the scripts, Jupyter Notebooks, but I do want a report with your assignments. It doesn't have to be fancy, but just a PDF or a Word doc with screenshots, everything, and a few comments here and there of what you did. Yeah.
So for the reports, it's more of like a screenshot of the code and then like
A screenshot of the result, and then maybe highlighting the change that you had to make for it to work. You don't, because the code is really the code I provide. You're really using my code most of the time, but you are modifying. So you just highlight. And then you can attach your solution, but I just want you to have a report in there.
you report like the proper APA stuff, or it's just like
No, I don't care about that, but I do care about the substance of it though. So really the way that I answer this question is like this. Provide enough evidence that you did the task. So what does that mean? It means you understand the topic, then you understand the question. So if you understand the topic and the question, you know when you have the right answer. Because you will argue with me until I finally give you the grade if you know you've done it right, right? So that's it. I just need enough evidence to prove that you did it correctly.
Okay.
If you can do that with one, then that's great. One screenshot. Usually, actually, if a student gives me 30 screenshots of something, they don't know what. That's the reality, right? Any other questions, guys? Yeah, please. Yep.
And then
Yes. Yeah, so try to attend, even though I am recording everything, right? And that's basically to help you. I think you are required to come to class. You can miss a few, right? But if I haven't seen you in 3 weeks, that might be a problem. Anything else, guys? That's not my policy, it's university policy. Yes.
The lab is required.
To attend? I believe so. I think so. Ask the administrators. I don't know. I'm just following their instructions. All right. So let's continue. All right. So and this is the actual course schedule that I'll follow. So basically this week I'll show you Anaconda and how to there's this thing I called word problems. And what these word problems are is basically I'll give you like a paragraph and then I ask you to just like answer certain questions. I'll have like 5 questions that I want you to answer. So they're basically something called what is the X matrix? What are the shapes of the X matrix? What is the Y vector? What is the shape of the Y vector? And you'll see, I'll provide some examples of that. So that's the first, and that's really just what that's trying to teach you is how do I take any problem and summarize it into something that I can use for machine learning, right? That's kind of what we're trying to learn there. And we will see that basically most machine learning algorithms will take something called a X matrix and a Y vector. So if you know how to convert an image problem or a text problem or a networking problem into that, you can basically solve any problem, or at least start to solve any problem with machine learning, right? So we'll look at that this week. Then we have to get into the vector space model features. I'll get into tensor operations, basic linear algebra. So this is something that hopefully you've covered already in the Intro to AI course. Linear algebra is the one part of mathematics that is really important to machine learning, okay? Now, are you required to know everything about linear algebra? No. But within the topic of linear algebra, there are certain operations that you really want to understand how to do because they just make things easier. So initially you may resist it and not like it, but eventually you do learn to appreciate it. And if, this is not a math course, so I'm not going to teach you like the why or give you the proof, right, of why this math operation works, but we can just mechanically learn how to do these operations. All right, so I have a set of about 80 problems that are just things that I just ask students to kind of just do mechanically. And I promise you, if you do all 80, it starts to click in your head how the operations work. Do you see what I'm saying? So you guys know how to add and do a multiplication and subtract, right? So now you just have to do those same operations, but in this context of matrices and vectors. Okay, and so if you learn those basic operations, it'll help you to understand the algorithms going forward. The reason why we need to do that is we can't really use for loops in machine learning. It would just be too slow. We'd never get anywhere. So we have to find like optimized ways of doing operations, and these tensor operations improve that process and allow us to do things much, much faster. Do you guys understand the reason? So we have to understand those operations just to be efficient and fast. Okay, so we'll take a look at that, and like I said, I'll maybe start a little bit of it this week, and then next week I want to get everyone to do this. So these problems I've already added on my GitHub, so you can just go through them mechanically, okay, and kind of develop some muscle memory, if you will, of how they work. Questions about that? All right, so that's kind of the one thing that's a foundation that I think you need to have, and that's why I spend a week on it, basically, on these operations. Because I do think once you have this, then everything else going forward is going to be much easier to understand. All right, after that, the next week, we will cover Weka. Weka is, like I said, that GUI version of or tool in machine learning. And that's just a really nice tool to learn how to go from beginning to end in machine learning. So we're going to look at a lot of algorithms, data sets, and then, okay, how do we take this data set, train a model, measure performance? How do we take now this data set, train a model, measure performance. And so you'll learn the whole pipeline really quickly instead of having to spend a lot of time on the algorithm, getting that to work. And by doing that, you're focusing so much on that that you're missing the big picture. Do you see what I'm saying? So what I like about Weka is it allows you to get the big picture really quickly. All right, so we'll take a look at that, Weka. And then finally, we start to get, so most of these are just either background or the whole machine learning pipeline. Once we're done with that, we start getting into the algorithms, the specific algorithms. And so that's going to be KNN. I like to start with that one. So this will be your first algorithm that you have to implement from scratch. And we're just going to use NumPy for this one. So not even like advanced libraries. You're literally like building it from scratch. This is called the K-nearest algorithm. And then we'll do the same for a few other algorithms. I'm not going to cover all of these. But one I want to cover is hot field networks. So this is the one that won the Nobel Prize. So you should know a little bit about it. And it's an important one. It's very interesting also. It's different a little bit. So because what's interesting about the hot field network is it's actually meant to be a way of representing memory. So most of these algorithms are inference. Given an input, I say something about that and provide an output, like, is this a cat or a dog? Yes or no. But hot field networks are like memory. So how do I have ideas stored in my brain? Like, for instance, how do you remember that, something that when you went to high school, right? How do you remember your senior year in high school, right? That's memories. And so hot field networks are a mathematical or a computational way of storing very simple information, obviously, but very interesting. So we'll look at this one and implement it from scratch. We will, of course, implement the perceptron from scratch, which is the first neural network, and then we'll implement a multi-layer perceptron also from scratch. So those will be the algorithms that like the traditional algorithms that I want to cover from scratch. After that, I probably won't have time to implement decision trees from scratch, but we will cover XGBoost, and you'll know how to use that. It's just a library. It's very straightforward. It's like you can treat it based. So here's an important thing. It's important that you understand all algorithms, but some algorithms you can just treat as a black box. Do you know what I mean by that? It basically means you take data, convert it into some format, it goes into this black box, and then you get an output. So this will be the approach that I take for something like XGBoost. But XGBoost is actually based on these decision tree algorithms, right? So we could obviously try to code this from scratch, but it would just take too long. So I may not have time for that one, but I will have time for KNN, hot field networks, and the neural network types of things. Well, obviously that's the hot topic in machine learning, so we'll spend most of our time on that. If time permits, we might do a very simple naive Bayes. This is yet another way of doing machine learning, not neural network based, not tree based, not vector space based, but just probabilistic based. Like, how you guys can predict probabilities, right? So what's the probability that it's gonna be sunny on Friday? What's the probability that it's gonna be 72 degrees on Friday? It's the Midwest, so it's possible. It's possible. It's possible. But what's the probability that it's going to be 72 degrees on Friday?
60.
60?
Solid 60.
A solid. Do you guys
If it was
agree?
April, it'd be higher.
Yeah. Okay. All right. Yeah, exactly. And that's the point, right? That through probabilities, we can predict things. Do you see that? And so that's what probabilistic algorithms are about. And so we can, if time permits, I would cover this one, but we'll see. All right. So anyway, but we will cover naive Bayes, KNN, all these basically with Weka as a black box. And then we'll focus on certain ones to understand the algorithm. Make sense? All right. After that, we'll learn a tool in Python called, not Python, in HTML called PyScript. So PyScript is a way that we can put Python code in an HTML website. So that's useful because it allows you to deploy a machine learning algorithm to your website. Do you see what I'm saying? So we'll do this twice. We'll learn how to, so basically the idea here is how to deploy your machine learning algorithms. We can use GitHub for this. GitHub has something called Pages, which allows you to set up websites, static websites. And so we will look at PyScript for deploying something like a KNN. And then later we will look at something called Onyx to deploy deep learning algorithms, all right, to a website so that you can actually deploy your solutions and they're available via URL. So we'll look at that. So here, this just continues with the traditional algorithms because that might take some time. After that, basically this is around, after the first exam, we will look at neural networks, the perceptron. So that sequence goes from the perceptron, linear regression, logistic regression, to the neural network called a multi-layer perceptron, and then deep learning. So it's very nice. It's a very nice sequence where we learn something one week, and the next week we just say, okay, now let's take what we just learned, but let's just modify like 3 things, and boom, we have a new algorithm. And then the following week, okay, now let's take the previous one and just modify this. So as you can see, we're just building on top of what we just defined previously, okay? So this is where we will use PyTorch, for instance, to do that. And that's why, for instance, there's an MLP, which only has 1 hidden layer, and you want to make it deep, just more layers, you see? And that's basically it. So you should have a good understanding of how deep learning works once we get to that. Now, is that all of deep learning? No, because beyond that, there's more advanced algorithms. Something called a convolutional neural network, recurrent neural networks, transformers. There's a whole bunch. Those topics I won't cover in this class because there just isn't enough time. The only thing I will cover in this course beyond the basic deep learning is CNNs, and we will look at something called a ResNet, just to kind of give you an idea of what a really advanced algorithm is like. Okay, but that will be towards the end of the semester. Any questions, guys? Make sense? If you're interested in more advanced algorithms, as I say, you can take 520 or 530, which cover way more advanced. All right. All right. So that's these. Onyx, I already talked about that. You can see here we'll cover PyTorch, and then finally, as I said, basic CNNs and a ResNet. As it's important, I believe, even though this is a foundations class, that you do get a sense of what state of the art is. And then special topics, I haven't decided what we'll cover. All right. Here's the mandated university emergency procedures. So take a look at that, please. Read the syllabus. You should read the syllabus, everything. And that's it. That's the syllabus, basically. All right, so let's go back to the table of contents. Okay, so we've covered that. For the project, I don't know what I'm going to do for the project this semester. In the past, I have done competitions, and the reason why I do that is basically machine learning is competitions. So there's always a challenge. There's always companies or people that participate, and then somebody wins and it becomes the next big company or something like that. So because a lot of machine learning algorithms are usually associated with some metric that they're trying to increase, right? So they're trying to get better performance, better accuracy, better in this score or that score. So for instance, right now, if you think about something like the GPTs from OpenAI, you constantly see, we use the latest version of ChatGPT on these metrics, and the last time around, it was scoring around 0.25, now it's 0.60. So it's a huge improvement. And by the way, the human falls at 0.45, so it's now smarter than humans. You know what I mean? So a lot of machine learning is measured that way. So for instance, for ChatGPT, what they're using right now, I think, is high school exams, right? So high school comprehension exams or high school math exams. So they give those problems to the ChatGPT models, and then they solve these things, and then they grade them, and they'll say humans will score on average about 70 on this, whereas ChatGPT was scoring 20 before. Now it might be scoring 80. Eventually, it'll score 100, and so that's how they're trying to measure how intelligent it is. Does that make sense? By these metrics, you can look it up. So they usually publish papers about it. All right, so that's all right. So resources, this is kind of where you can find everything. If you're looking for the code for this class, that's going to be on the GitHub here. Usually this is where I post most of my scripts. I don't post code on Brightspace, right? So it's instead you can look for it here. I'm recording. I'll try to record all the sessions. And I'll post the videos here on this YouTube channel, so you can just go there and get access to it. I may load other things. I guess I loaded this file last semester. It's a credit card data file. So let's take a look at the GitHub real quick. As I said, I usually just give you all the code examples. This is basically the GitHub for this class for 365. So a lot of the algorithms are here, right? You know, KNN, etc. And then neural networks related algorithms and so on. So this is a good resource for everything, all the examples that you will need in the class. Any questions about this? All right. So let's go back. Table of contents. GPU Scholar. So this is the information for GPU Scholar. So as I said, this is the cloud service so that we can use GPUs. This is not available yet. I haven't requested this, but I'll do this week. So in a couple of weeks or so, you'll be able to log in here, and then I'll demo how to go to the website and request a GPU and everything. Basically, it'll be the same approach. You'll use Anaconda, but you'll just be on the GPU in the cloud. Okay. All right, so I think that's everything as far as the introduction, and now we're ready to start with the topics. Okay, so the first topics are going to be the ML pipeline and this thing that I call the word problem, so ML problem definition. Right, so that's usually where the things I like to do in the beginning is I just have problems. You know, how do we build a model to find network attacks? Right, and so we have to think about that problem. We have to think, okay, well, that we would get this data, you know, and then these are the features, this, you know, so we need to provide a way of structuring this data so that it can be used to solve a problem. So this will be the first thing we cover today. The other thing I want to cover is the environment, as someone asked, and that's going to be Anaconda. So what you need to do, I'm using a Windows machine. I assume most of you will use a Windows machine, but if you're using Mac or Linux, that should be very straightforward to install the software. So you are going to need to, let's say you're using Windows, so you go to Anaconda. And this is the website, and then basically just download the Anaconda installer, basically. Okay, this is going to be our environment for most of the semester. Okay, the only other tool we have to install is really the Weka program, which is something separate from this. Okay, any questions about this, guys? This is the software, all right? So we'll start using this either this week on Wednesday or next week, all right? So everything will be done through here. So you just have to install it. Should be, let's say, installing. There we go. It's free. Hmm? Yeah, just Google Anaconda. So what I did here.
Yeah, I'm right there, but.
Oh, really? Does it really ask for? Okay. That might be a new thing. You can put in your, you shouldn't, there's no license required or anything like, you don't have to pay. Yeah, it's free. It's free. So you just go to installing Anaconda and then you install for Windows. There should be a link to download. Is big? Yeah, it might be big. But yeah, that's the website. I think yeah, so Anaconda installers, if you're using Mac, well, you'll install the Mac version or the Linux, or in my case, I used for Windows. Got it? So you download it, double click, follow the wizard, and you should have it. Any questions about that, guys? So that's the first task, right, that you should do is just make sure you install Anaconda on your operating system. All right, I'm not hearing any questions, so I assume you guys understand how to do that. All right, so let's move on now, and let's assume that you've already installed Anaconda. So, and I'm recording this, okay? So now, how do you get access to Anaconda, right? So there's probably a few ways of doing that. The way that I do it is I just click on my programs, right? And then you can click on all. And then you should have something called Anaconda here. And I use the Anaconda prompt. Okay. Got it? Right. So click on the Anaconda prompt and it'll open up this terminal. There we go. And you should have basically your familiar Windows path, but it should also have this that says base. That tells you that Anaconda has already been installed on that operating system. And this is basically the idea of environments, okay? So let's say we're building a complicated deep neural network with Torch. So we're going to need the latest libraries, right? But then also we may want to build a KNN with a simpler version of Torch, for instance, right? So then what we can do is, since we may need to have different versions of the libraries, you want to create maybe one environment for this problem and another environment for this other problem. And like that, you can have multiple environments, right? So this is a very nice solution. So that's the advantage of using Anaconda. So then here's a few of the commands that you're going to need. First of all, the files are independent from Anaconda. So that's just the basic file system structure of your operating system, okay? So remember that this is Windows, so you use something like dir to list the directories. Everyone with me? And then you want to create a directory where you're going to have all your files, right? So we're going to navigate to the desktop here. So to do that, let me do this. Yeah. So I'm going to do cd desktop, okay? Then CLS should clear the screen. Now I can do dir and you can see I have all the files on my desktop. So the next thing I want to do is I want to create a folder for my files. So in this case, here I'm going to create a folder, new, and I'm going to call it ITS 365, and this is 2025 spring. You see that? So this is where all my files are going to live for this semester. And so I can go back to my prompt here, dir, and I should have that folder, right? So it's ITS 365 2025 spring. So this is where I want to put all my files. This is, as I said, independent from Anaconda. So Anaconda is just for the version control of the libraries. And then this, the folder is going to be just in the file system. So now I want to go into that folder. So I'm going to do ITS 365 2025. 2025. Okay, 2025 spring. Can't see because of this thing. All right. So CD, ITS 365, 2025 spring. There we go. So now I'm in that folder and there should be nothing in there. That's Linux, EIR. So there's nothing in there, right? So this is where I'm going to have all my code files, all my data, etc. for this semester. And I recommend that you do the same. Everyone with me? All right, so now let's go back to Anaconda. So currently I'm in the base environment of Anaconda. But really what I want to do is create a new environment where I'm going to install all my libraries for the first set of problems. And then eventually it may happen maybe at week 4 that we decide, you know what? These are different versions of the libraries. I'm going to create another environment and so on. So what are some of the Anaconda commands? So the very first one that you need to use is conda environment list. So this command will list all the environments that I've created in Anaconda for machine learning. So you can see I usually have this convention that I write Pi 39, Pi 38, Pi 37. And what that means is that I'm using that version of Python, for instance. I have some environments that are Pi 310, and that's Python 3.10. These are Python 3.9, 3.8, 3.7. So 3.7 at this point is starting to get a little old. And so I think I like using Python 3.8 just because I think it's like just right. Not too old, not too new. But it just depends on the library. So I'll usually say, by default, I'll probably use 3.8 or I'll say use 3.10 for this or something. So there's a new library right now called SMOL agents from Hugging Face, and that library only works in Python 3.10 or greater. You see that? But most of the things that we're gonna, if we're using just plain NumPy, Python 3.8 is sufficient. Does that make sense how that works, guys? All right, so, but what I like to do, just to illustrate how this works, is to create a new environment, and I'll probably remove some of these in the next few days. So I'll probably, this is, so this would be like 365 from probably last semester. I'll just get rid of it. All right, and I'll create a new one. So how do we do that? So let's do CLS. And I'm going to create a new environment. So I'm going to do conda create -- name. And I need to give it a name. I want to know that I'm using Python. I'm going to use Python 3.8. So I'm going to say Pi 38. And then I'm going to say what this is for. So ITS 365. And I'm going to say S 2005, just so I know. It's just so I know to go to this environment. 2025, right? Does this make sense? This is just the name, but I want a descriptive name, especially because I have several environments in it. You can give it whatever name you want. And then usually the only thing I define here is the Python version because I already know what I want. So in this case, I'll say Python 3.8. You can usually add more libraries, but I do that later. Got it? Any questions? So this is how you create an environment in Anaconda. Okay, so I'm going to hit enter. And we're going to give it a minute, and it's going to try to set up the environment. And it installs several libraries by default. But this is a very just basic installation of the Python environment for the course. Basically, every week we'll be adding 3 new libraries that we're going to be using. And that's how Python works, basically. All right, so it's saying that it's going to install these libraries. So you can see pip is a really important one. How many of you have used pip before? Show of hands. All right, some of you. Yeah, so pip is, I love pip, right? So I have to say that. So, especially 15 years ago when I had to install things on Linux, it was not fun. So I definitely appreciate something like pip today. So using Anaconda and using pip, what's really nice about it is you say, I want this library, but it's also going to install all the dependencies. And it does a really good job so that everything is going to work. So very nice library. So you can see it's got SQLite, Python setup tools, which is an installation thing. It even has OpenSSL certificates. So it's just installing some basic things. So all you have to do is say yes here, and we're going to let it install. So again, your task for this week, install Anaconda from the website for your operating system. Should be straightforward. And then once you do that, open the Anaconda prompt as I did, and then just set up your environment. Okay. So I do this all the time. It might be that sometimes you just need to do something. So you set up an environment, you run your script, generate your data, save it up to your GitHub, remove that environment, and you're done. So it's installing several things. We're not going to be using PyTorch for the first few weeks, but we will be using NumPy for the first few weeks. So that's the main library that I need. Maybe matplotlib so that we can visualize things. Okay. So, okay, it finished. And now it's saying that I need to activate my environment. So I'm going to do CLS. I'm going to do conda environment list, right? Just to see that I did, in fact, create the environment. So it should be here. There it is. Pi38, ITS 365, and then spring 2025. So now what I want to do is I want to activate this environment, okay? So remember, by default, you're going to be in the base environment, but what you want to do now is instantiate the new environment. So I'm going to do conda activate. And I have to, it doesn't autocomplete for this. So I'll say Pi38 ITS 365, and then S, and then 2025, just like that. So you go ahead and you activate it, and then what should happen is this base has changed to the actual environment. So this is how you know that you are now in this environment. So now maybe base has a version of Python that is Python 3.7. Well, you know for a fact that this environment has Python 3.8. It may just so happen that before you had installed Torch in base, but now if you try to invoke Torch in this one, it's not going to be there. Does that make sense? So you have to install it. So now, you can continue to install things here. So let's say, for instance, that we wanted to install Torch. So now you would use that program that I talked about just a second ago called pip. Pip is really nice, right? It allows you to install programs. So the way it works is you would say pip install and then something like Torch, and you would install that library. Or you say pip install NumPy. Now, keep in mind, sometimes if you install pip, it'll install a whole bunch of other libraries as well. So it might just install NumPy without you telling it to do that. But you can also do this. So so we can install all of our programs this way, or we can install our programs on the Jupyter notebook itself. So what I usually do sometimes is I just install Torch here and then install Jupyter, and then boom, move to the Jupyter and install the rest over there. Since we don't need Torch for the first few weeks, then I'm just going to go ahead and install Jupyter, or we don't need Torch, sorry. So to install the Jupyter notebook, so someone had talked about IDEs, this is sort of the ID that I'm using in the class. It's very nice for like visualization and things like that. So what you do is you should type pip install Jupyter, just like that. You hit enter, and it's going to take a while. And this is going to be our environment, basically. Give me an error. Okay. Did you guys get an error for this when you installed it? That's very strange. So it seems to not want to do it. So we could do a couple of things. We could troubleshoot and try to figure out what this error is, or let's just install another environment with Python 3.7 instead. You see what I'm saying? So one or the other. I honestly don't know why it gave me that error. So let's do CLS. All right. So I'm going to do conda environment list. Right. And I'm going to create a new environment, conda create dash name. I'm going to say Python 3.7. So I'm going to install another version of Python, assuming that this, because it's an older version of Python, it might be more compatible with Jupyter. So I'm going to say here 2025 ITS 365. And then Python 3.7. See that? So conda create. Okay, so that should be. And then I'll have to figure out why it gave me the error later. Huh. Did you guys try this version also? Did it give you, you're getting the same error? This is very odd. I wonder if this is, could be an Anaconda problem, or it could be a university problem. I've never seen this before. For 3.7. Huh. I literally almost want to say that there's something going on with the network. I mean, let me look up the command just in case, but it's always something. See, I'm using this command, command conda create dash dash name, the name, the version of Python. Let's see. Do you guys see anything in the error? It just says OpenSSL appears to be unavailable on this machine, but it's also it's not working for you guys, so it's not localized to my machine. You're all getting the same error. OpenSSL is required to download and install packages. HTTPS connection. Retries. Could be the website that's down. Oh, so one thing I didn't do actually, I just noticed. Notice that my environment, I'm still in Pi 38. So conda deactivate. I should have done that. Okay, so I'm out of that environment and I'm back to the base environment. So let's try it again. So conda create dash dash name Pi 37 2025. Do you guys understand what I'm saying? I was running that in the Pi 38 environment and I should have left it before doing it. So let's try it again. Did everyone sign in? So here's that OpenSSL thing. It seems to be the problem. So let's do yes. Okay, so it did it. And now it says copy this. So contact Pi 37 2025. This. So there it is. Conda activate Pi 37 2025 365. So as you can see, the environment has changed from base to Pi 37. This is a different version of Python. The problem I had was with Jupyter. Let me just do pip install torch first. Even though we're not going to use it yet, it doesn't affect anything. So let's install it and see what happens. Any luck? Did anyone manage to install everything successfully? You did? Do you have the Jupyter notebook open yet or no? Okay. All right. So let's see what happens here. All right. So trying to install Torch, which is a big library. And because I'm installing Torch, it's probably going to install NumPy. So you can see it says successfully installed. So I'm assuming everything's correct. So now we need to install Jupyter. So that would be pip install Jupyter. I think it's spelled like Jupyter. Yeah. So hit enter. So it's doing that.
Before we do pip install.
I did.
Is that a requirement for
I-
everyone?
Well, then you're going to be installing everything on your base environment, which I don't recommend. but it should work on the base. It's just, I don't like to do that.
Hmm.
Still trying to finish. I mean, it's still processing. All right, so no errors this time. So no issues with 3.7. 3.7 should be fine. I have installed 3.8, I'm sure. So it's just one of those things. I have to look it up. But this should be fine, right? And that's the beauty of Anaconda. So I installed Jupyter, I installed Torch, and that should be it. So at this point, we should be ready to start the Jupyter environment. So how do you do that? To answer your question, notice that I'm using here an environment. What's your name? Sorry.
Oh, Jake.
Jake. So you can see I'm not using the base environment. I did create that environment. You see that here highlighted in
Oh, yeah, I see it.
All right. So hopefully I've installed Jupyter now. I had Torch in there. So basically every time we have a class, etc., you would have to go to the start button, Jupyter prompt, open the Jupyter prompt, activate your environment, and then basically you would type, since you've already installed the basic libraries, right? You would just run Jupyter. So the way that you run it is you type Jupyter and then you have to say notebook. Okay, there's something called Jupyter Lab, but I usually just use Jupyter Notebooks. And basically the idea is that you have a notebook where you can write equations, write text, put images, and also have code that runs. That's really nice. So, okay, let's see if it works. So if I hit Jupyter Notebook, it should start a web interface where I can do all of my coding. And that would be the IDE. Now, if some of you have preferred IDEs, right? Use that, right? So you can use Cursor, VS Code, whatever you want. That's fine, but I'll be using this. Okay. We're not really debugging, right? So when you're writing code, you're writing code from scratch and you're like debugging and everything. Here, the algorithms are already written, right? They're already on my GitHub. So we're just really copying them, modifying them, and we're trying to understand them. All right, so it's did it work? Yeah. So here it is, right? So what it did is, if you notice, I hit Jupyter Notebook, and then you get this. Don't kill this screen, because if you kill this screen, you're going to kill the browser interface, right? So think of it as you just created like a web server, and you're basically serving web pages. So now leave this as is, and then you can go to your browser, which in this case, by default, for me, it's using the Firefox browser. So this is our environment. We have a few tabs like running and files, which is what I basically use. Running, once we start running our scripts, they're going to appear here. But we don't have anything running right now, so there's nothing. So now, if you want to start a new Jupyter Notebook, this is just kind of like the contents of the directory. What you do is you go to New, click New, and you select Python 3, which is going to give you that version of Python that you're using, which is 3.7. Do you guys see that? Make sense? All right, and there it is. This is a Jupyter Notebook. So basically you have these cells, you write code here, you run it, and then it'll print out the output like underneath. So you can have multiple cells. So you can add them simply by clicking on this plus button. So you can just go ahead and do that. See that? You probably want to rename it because currently it's called untitled. So you go to File, Rename, and this is going to be some basic tensor operations with NumPy. So I'm just going to say tensor ops example 1, something like that. You guys see that? I'm just showing you the environment, but on Thursday or Wednesday when we come back, we'll start doing some matrix multiplications, things like that, to get started with this. And also, I know we're out of time, and we're also going to start doing some word problems on Wednesday. So that'll be the goal. I'll give you a few problems, how to implement a machine learning algorithm that detects network attacks or that identifies, if it's a cat or a dog in an image, something like that. But they're just going to be word problems, no coding, but we will use this to start doing tensor operations. So for now, let's just make sure everything works. So what I want to know is I installed the torch library in the environment. So now I want to see if it loads. So to do that, I would type import torch. And if you notice, this is just regular Python code. So if I install this properly, then it's just going to load. If not, it's going to give me an error. So you write some code, and then here you have to click on this button, run. You can see that it's thinking here, and also this is solid. So now it's not solid. It means that it completed. It gave this a number, and you can see there's no error in the output. So it tells you that you installed it correctly. Does that make sense, guys? That's it. That's a Jupyter Notebook. The main library that we will use on Wednesday is NumPy. So import NumPy as NP, right? So this by default should have been installed, but otherwise we'll need to install it. Okay, so it didn't install. All right, so what do I do then? Do I have to kill this and go back to the prompt? No, I can install things directly here. So this is a good thing. So these are just my conventions. You don't have to do it like this, but what I do is I add a cell, and I like to leave like the things that I installed into Jupyter for reference. So I'll do something like this. So I need to install NumPy. So I'll do pip install NumPy, right? So if I have these 2 pound signs in here, as you know, in Python, that means this is commented out. So I'm going to remove it. Notice the exclamation point that's required for it to run in Jupyter. So now I'm going to go ahead and install this on my environment, but from Jupyter Notebooks. So I hit run, let it think a little bit. You can see the star, you can see the solid. Okay, gave you some output saying that it installed the library successfully. So now I'm going to leave it here as reference, but it's commented out. And now I'm going to test it to see if it loads. So I'm going to save actually. Hit run. And it just loaded. See, there's a 5 here. This is not solid anymore. And so we have NumPy. So we're ready to go. Got it? All right. So you need to have this working until here for Wednesday. And then on Wednesday, so I finished we're almost done with the class today. I've gone over the syllabus. I kind of gave you a description of what the course is about. And I've shown you how to install and configure your environment. Okay. So we're done with that. On Wednesday, we will do 3 to 5 word problems, and you'll have your first homework assignment. And we will go over using this environment to perform some what I call tensor operations. We'll define what a tensor is, and then basically tensor ties into the data. So it's like we have data, and we're going to start doing some math operations that are essential both to machine learning and also for us to get acquainted with this environment. Got it? Everyone with me? All right, guys, so we can stop here for today, and I will see you Wednesday.